Hi, I am Ms.S.SARANYA, Assistant Professor, Department of Computer Science. Today we are going to see about disk scheduling algorithms. Disk scheduling, it is the function of an operating system. Actually, it is the one of the function of an operating system. There are many other functions which are process management, memory management, security and control. Now we are going to see about the goal of disk scheduling. The main goal of disk scheduling are to optimize the performance of disk operations, reduce the time it takes to access the data and improve overall system efficiency. Disk scheduling is also known as input-output scheduling. Its importance: multiple input-output requests may arrive by different processes and only one input-output request can be served at a time by the disk controller. Thus, other input-output requests need to wait in the waiting queue and need to be scheduled. Hard drives are one of the slowest part of computer system and thus need to be accessed in an efficient manner. Before we are going to see about the types of disk scheduling, we need to know some of the important terms, that is seek time, rotation latency and transfer time. Seek time means it is the time taken by the disk head to move to the required track. Rotational latency, time taken for the desired sector to rotate under read and write head. Transfer time, time taken to actually transfer the data from disk to memory. Formula to calculate disk access time. Disk access time equal to seek time plus rotational latency plus transfer time. Here is an example. Move to track, find sector, transfer data. This is the basic order to read data from the disk. Some of the disk scheduling algorithms are here. The first one is FCFS. FCFS means first come first serve. FCFS is the simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. The algorithm looks very fair and there is no starvation. All requests are serviced sequentially, but generally it does not provide the fastest response. The process steps for the FCFS are: the request array contains the index of the requested track, sorted in ascending order of the arrival time. Head is the position of the disk head. Process each track in the request array according to the order in which the request arrived. Calculate the absolute distance between the current head position and the requested track. Add this distance to the total seek count. Update the current position to the track that has been serviced. Repeat the above steps until every track in the request array has been serviced. Now we are going to see about one example. These are the request sequence. It starts from 176, 79, 34, 60, 92, 11, 41 and 114. Initially the head position is in 50. Here we are going to represent about the chart sequence. The number represents the track number on the disk where different data requests are located. It starts from 50. This is the current position of the disk head. Each subtraction represents the distance traveled by the disk head from one request to the next. We use the absolute difference because we only want to know how far the head moves, not the direction. Here it starts from 176 to till 114. Everything will be calculated and the final answer will be the total seek count. Advantages of FCFS: it is very simple and easy to implement. Fair, but requests are handled in arrival order. No request is deliberately ignored. Disadvantages: can cause large disk head movement. High waiting time may occur. Overall performance is usually lower than more optimized algorithm. Next, we are going to see about SSTF, shortest seek time first. It selects the request closest to the current disk on position to minimize the seek time. It improves performance compared to FCFS by reducing average response time and increasing system throughput. Process steps: selects the request with minimum seek time. Execute request closest to the disk head first. Reduces average seek time and improves efficiency. Example: the request sequence is 176, 79, 34, 60, 92, 11, 41 and 114. Initial head position is in 50. When comparing both the request from the initial head portion, 41 is closest to 50 than 60. So it starts from 41, it will finish all the request and it goes to the opposite direction. So finally, with all the traveling time, we are calculating the total seek count. It is as 204. Advantages of SSTF: reduces head movement compared with FCFS in many cases, provides better average response time, generally gives better performance than FCFS. Disadvantages: a request far from current head may experience long waiting time. Starvation can occur, more difficult to implement than FCFS. Next, we are going to see about scan. In this algorithm, the disk arm moves in one direction, servicing request along the way, and the reverse direction at the end, similar to an elevator. So it is also known as elevator algorithm. It provides better performance than simple algorithm but may cause longer waiting time for some request. Process steps: disk or move in one direction, servicing request, reverse directions after reaching the end. Mid-range requests are served faster, others may wait longer. Here is an example. The request sequence is same as the above previous examples. Here it starts, moves in one direction, serves all the requests in that direction, reaches the end of the disk and then reverse the direction. Total seek operations will be 226 and the seek sequence is 41, 34, 11, 0, 60, 79, 92, 114, 176. Total seek count is calculated as 226. Advantages and disadvantages. Advantages: provides more uniform waiting time, reduce unnecessary head movement, less chance of starvation than SSTF. Suitable when there are many requests. Disadvantage: the head may travel to the end of the disk even when there is no request at the end. Request just begin, the head may have to wait for the head to return. More complex than FC. Next, we are going to see about C-scan. C-scan is also known as circular scan. Is an improvement over the scan algorithm where the disk arm moves in one direction only. Instead of reversing, it jumps back to the beginning of the disk and continues servicing request, providing more uniform wait times. Process steps: disk arm moves in one direction only. After reaching the end, it jumps to the beginning. Service request in a circular manner, provides more uniform waiting time compared to scan. Here is the example. Initial head portion is at 50. Instead of reversing, it jumps back to the beginning of the disk. The total seek count is calculated as 190. Advantages: provides more uniform waiting time, gives fair service to the request across the disk, suitable for system with many requests. Disadvantages: requires extra head movement when returning to the beginning, usually has more movement than look and see look, more complex than FCFS. Next, we are going to see about look. It is similar to scan, but instead of moving the disk arm to the end, it only goes up to the last pending request in that direction and then reverse, reducing unnecessary movement. Process steps: moves disk arm only up to the last request, not the disk end. Here this is the main important thing. Reverse direction after servicing the last request. Avoid unnecessary disk traversal. Improve efficiency and reduce seek time compared to scan. Here is the input sequence. Total seek operations will be 291. Here is an example. It starts from 50 and it's servicing all the requests. It goes to the last 176 and then it reverses back to the another request. Advantages: less head movement than scan. Faster because unnecessary movement to the disk end is avoided. Better efficiency. Disadvantage: request may still have to wait for the head to come back. Slightly more complex than FCFS. Waiting time can vary depending on request position. Next, we are going to see about CLOOK. C look is similar to ski scan but avoid unnecessary movement by going up only to the last request in one direction and then jumping to the last request at other direction instead of going to the disk extreme end. Advantages: provides more uniform waiting time for all requests, eliminates unnecessary movement by servicing only requested track. Disadvantage: requires a jump for the last request to the first request, more complex to implement than look and FFCS. Process steps: moves only up to the last request in one direction, jumps to the last request at other end, does not go to the physical disk end, reduce unnecessary movement and improve efficiency. Here is the chart representation of C look. Advantages: less head movement than C-scan, provides relatively uniform waiting time, avoids unnecessary movement to the physical end of the disk, efficient for heavy workloads. Disadvantages: the jumps from one end to the other can cause additional movement, more complex than FCFS. A request may have to wait for the next cycle. Thank you.